Okay, this is lesson 1.5, angle relationships. So we're going to look at angles in comparison to each other and what some of the relationships are. Okay, you don't need to write down every single one of these in your notes, but probably 2 pictures would be good. And I've highlighted this little portion in red to kind of set that apart. That's what we're looking at, this angle here and this angle here. I just want to eliminate some of the clutter of like naming it and all the vertex. In every single case here, these 2 angles form a straight line. So here's your straight line. Here's your straight line. Because of this, we call this pair of angles a linear pair. Every example here is a linear pair. And you can see that these form the right angle. Linear, not a right angle, I'm sorry. Those 2 form a straight line. A straight line is why it has the word linear. Okay, and you can see that in every example. Okay, in this case, our lines are perpendicular. So every example here, we have perpendicular lines. And they form right angles. Okay, or we could say 90 degrees. So if you look at this red one and this red one, those are each going to be 90 degrees. And the reason I know that is because I have a right angle marking right there. And generally, if you don't have a right angle marking, it's not, you cannot tell me it's 90 degrees unless you have a situation like this. I have a right angle here. That means this has to be 90, this has to be 90, this has to be 90. All 4 angles have to be 90 in that case. So here, the green mark and the green mark, that's an example of perpendicular lines forming right angles. Here, the red marks are formed by perpendicular lines. So these are right angles. Okay, once again, you only need probably 2 examples in your notes, and then you need the title of what this is. Once again, you might think, hey, this is a linear pair. There's 2 that are right beside each other. But the problem is these do not form a straight line. Maybe here they do, and that's a special case, but here they do not. These do not form a straight line. So we have to have a different vocabulary for them. And these are called adjacent. Okay, adjacent angles means basically the definition is next to. All right, so the next time when you're in class and you think, hey, I sit next to Frank, why don't you spiffy up your vocabulary a little bit and say, hey, I sit adjacent to Frank. All right, so adjacent means next to, and every sample here, our marked angles are next to the other angle. All right, in this case, they're obviously not adjacent, but we have a special term for this. They look kind of opposite, but that's not the word we want to use. We're going to say vertical angles. Okay, I know vertical makes you think of something high or tall. These are just basically on the other side. So here's this angle. To make this angle, you need these lines. That creates a whole other angle on the other side. And these are called vertical angles. It just so happens that these vertical angles are always going to be congruent. And we'll deal with that a lot more in future chapters. But right there you have it. Vertical angles are going to be congruent. These angles are considered vertical. These red ones are vertical. And this happens a lot too. If these are vertical, the green ones are then vertical. The red ones are vertical, the green ones are vertical. Green ones down here are vertical to each other. These 2 marked angles are vertical to each other. Vertical angles. Complementary angles and supplementary angles. Complementary angles add up to, or they have a sum of 90 degrees. Supplementary angles have a sum of 180 degrees. Well, how are we going to keep this straight? If you give somebody a compliment, you say, nice job on that math test. I might happen to give you a handshake at the same time. And a lot of times when you get a compliment, you might get a handshake. And if you think about the shape of your arm, and this is stretching it a bit, so work with me. If you stretch or shake a hand, your arm will form a 90-degree angle. 90-degree angle or a right angle. Compliment, you give a compliment to somebody, shake their hand, your arm forms a 90-degree angle, so then you have a sum of 90 degrees. The other one is supplementary, it's 180 degrees. If you have a better way of remembering that, let me know so we can share it with the class. Okay, example 1. Name 2 angles that form a linear pair. So we have to find a straight line, and I'm going to pick this straight line right here. And I just happen to have 2 angles. I've got this angle right here, and this one right here. So I say angle VZX and angle XZW are considered to be a linear pair. I can also pick right here. There's another straight line, and I'm going to pick this angle and this angle. So I'd say angle YZV and angle VZX are considered to be a linear pair. And that's about all the straight lines I have in that. I don't know if we want to call this, this, and this a linear trio, but I think we'll just stick to our linear pairs because that's what they're asking for. Example number 2, name 2 acute vertical angles. In this picture, that's about acute or not, I only see one set of vertical angles that are honest to goodness vertical angles. And we're going to pick this right here with this over here. Okay, vertical, kind of in your mind you're going to think opposite. So I need to name those, so I'm going to have angle X, V, oh that's not a V, oopsie, X, Z, W, and angle V, Z, Y. And that's your only pair of vertical angles. Example 3, find the measures of 2 supplementary angles if the measure of one angle is 6 less than 5 times the other angle. Okay, supplementary means the total is 180 degrees. A lot of times you're not going to get a picture with a problem like this. I need you to right away, one of the angles is unknown. The other angle, however, is 6 less than 5 times the other angle. 6 less than 5 times the other angle. That's how you write that. Do not write 6 minus 5x, because that's 5x less than 6 times the other angle. We don't want that. So we have 5x minus 6. All right, and these two are going to total up to 180 degrees. Oops, that's not as plus. Minus 6 equals 180. Okay, this x comes from here, and this comes from here. So now I'm going to just solve. I'm going to combine like terms, add 6 to both sides, divide both sides by 6. I get x is equal to 31. The question is, find the measures of the angles. I've got this one is taken care of. Okay, so if that's 31, you're probably like, hey, I think the other one's 149. Well, let's do the math. Okay, this is kind of how you check your work. So 31 times 5 is 155, and then I'm going to take away 6. Okay, it does end up being 149. And some of you were like, how'd you know that before you even did that? It's because they're supplementary. 31 plus something gives me 149, and this just allowed me to check my work. Example 4, find the measures of 2 complementary angles. If one angle measures 6 degrees less than 5 times the measure of the other angle. You're like, isn't this the same problem? Nope. Complementary. And notice they have no angles drawn. So this is a major tripping point for geometry students. So the first thing I'm going to tell you to do is draw the 2 angles. I don't even care if they're perfect. You're just going to get 2 of them now. Okay? I don't know if those add up to 90 if I were to actually take out my protractor. Actually, I probably know they do not, but this gives us started. And what did I say? Put down x in one of them. You don't know what one of those angles is. But the other one is 6 degrees less than 5 times the other. And it doesn't matter if you put the x in the big one or the small one. It'll all work out in the end. Okay? But the total of these two, since they're complementary, is going to be 90 degrees. So now, I take these two, set them equal to 90. Okay, so I've combined like terms, then I added 6, and then I'm dividing by 6, and I'm getting 16. Okay, so this angle is 16 degrees. And then a lot of you can take 90 minus 16 to figure out the other angle. If you do that, double check it with 16 times 5, which is 80, and then take away 6 from that, and you get 74 degrees. Is 74 plus 16, oh my goodness, who would have known? It ends up being 90 degrees. That's complementary. Example 5, find x so that line KO is perpendicular. That's our symbol for perpendicular. I think I forgot to mention that earlier. Okay, perpendicular, and they form a right angle, if you look at that, is perpendicular to line HM. Okay, so KO and line HM. Okay, so this forms a right angle when they're perpendicular, which means this is a right angle, which means this is a right angle, which means this is a right angle right here as well. Okay, if that's a right angle, then these two things add up. The 3x plus 6 plus the 9x add up to 90 degrees. Okay, combine like terms. Subtract 6 from both sides. Divide by 12. And we get x is equal to 7. Now I go back and it says find x. That's all I have to do. In order to check to see if this is right, 9 times 7 is 63. Okay, 7 times 3 is 21. 21 plus 6 is 27. Do 27 and 63. Oh my goodness, who would have guessed? It turns out to be 90 degrees. Oh my goodness. All right, so you could say those form a right angle. If you're really sneaky, you can say they're complementary. Example 6, determine whether the statement, the measure x of angle XAY, so here's XAY, is 90 degrees. Determine whether the statement can be assumed from the figure. All right, so you're looking at that going, sure, it looks like it's 90 degrees. Here's the thing about geometry. If they don't tell you in the write-up, and if they don't show you with a little right angle marking, you cannot assume it. Okay? So this is one of those things they might try to put on your MCAs or your ACTs, you know. Just do not look at that and assume that that's 90 degrees. You cannot say that that's going to be a right angle. So be on the lookout for that. And that ends today's lesson.